This is Jacob's Algebra, Chapter 11, Lesson 2, continuing with working on fractions, only this time fractions that actually involve algebra. So if you have a fraction a over b, you know that you can find an equivalent fraction by multiplying both the numerator and the denominator by some number n. So na over nb is equal to a over b with the rule that n cannot be 0. Because if n is 0, then you're going to be dividing by 0, and that's not allowed. That would be undefined. So the denominator of a fraction can never be 0. Well, what if we have a fraction like x minus 1 over x squared minus 1? We can actually simplify that. Anytime that you have a fraction that involves variables, you want to look at see if you can factor anything. And the denominator is the difference of two squares. So we can copy our numerator, x minus 1, and then our denominator, we have two squares we're taking the difference of. So that's going to factor us x plus 1 times x minus 1. Now, looking at this, it's really easy to tell what values x cannot be. X cannot be 1 or negative 1, because if x equals 1, then x minus 1 will be 0. Or if x equals negative 1, then x plus 1 will be 0. So those are values that x cannot be. Now, looking at our fraction, let's see if we can simplify. We have x minus 1 as a factor in the denominator, so we can divide x minus 1 into the numerator and the denominator, and we will end up with 1 over x plus 1. Now, we still can't have x ever equal a positive 1, because if x equals a positive 1 in our original equation, we will end up with 0 in our denominator. So x cannot equal a positive 1 or a negative 1 ever for this equation. Let's try a different one. What if we have 3x minus 6 divided by 5x minus 10? Well, again, first thing you want to do is try factoring. In our numerator, is there a greatest common factor? Well, the greatest common factor is going to be 3. And so 3 times x will be 3x. 3 times negative 2 will give us our negative 6. Now we'll try our denominator. Greatest common factor between 5x and negative 10 is 5. And we draw our parentheses. 5 times x will give us 5x. 5 times a negative 2 will give us our negative 10. Now looking at this, you can see immediately that x cannot equal 2. Because if x equals 2, our denominator is going to be 0. So now we can divide both our numerator and our denominator by x minus 2, because that is a common term in both the numerator and the denominator. And so we end up with the fraction 3/5. But still, x cannot equal 2, because if x equals 2 and we plug that into our original equation, we will end up dividing by 0, which is not allowed. Okay. So that goes back to now we get to our problems. So anytime you have an algebraic fraction, before you do any elimination of terms, you have to find out what x cannot equal. You can't get all the way to the end and finish simplifying and say, oh, there's no limits on x because we end up with a constant 3/5. Well, still, yes, you will get 3/5 for your answer every time, no matter what you plug in for x, unless you plug in 2 for x. If you plug in 2 for x, your answer will be undefined. Okay, so let's start our first problem. Number 4, it says the denominator of a fraction cannot be allowed to be 0. What values of x, if any, would make the denominator of each of the following fractions equal to 0? So we want to find what values are not allowed for x. So for part A, we have 2 over x. So what values would make our denominator 0? Well, our denominator is just x. So if x equals 0, that will make our denominator 0. So 0 is our answer for part A. For part B, we have 3 over x minus 1. Well, what values of x would make our denominator 0? Our denominator is x minus 1. If x equals 1, that will make our denominator 0. So that is the value that is not allowed. So now let's skip over to part D. Part D is 2x minus 1 over 7. So what values of x are not allowed? What values of x will cause our denominator to be 0? Well, there isn't an x in the denominator. So x can be anything. There are no values of x that will make the fraction undefined. So this would be none. There are no values of x that make this fraction equal to, that make the denominator equal to 0. Okay, then let's look at part E. We have 1 over x squared minus 4. Okay, you always want to try factoring. So this is a difference of two squares because x squared is the square of x and 4 is the square of 2. And when you have the difference of two squares, you write your first term plus your second term, multiply by your first term minus your second term. So looking at this, it's easy to see what values x cannot be. Our first parentheses will become 0 if x equals negative 2. Our second parentheses will be 0 if x equals positive 2. So x equals plus or minus 2, and you can write plus 2 comma minus 2. Those are the values that x cannot be, because if x equals plus 2 or minus 2, our denominator will be 0. Okay, the last one we're going to look at is part F, 1 over x squared plus 4. This is not factorable because this is a sum of two squares, and there's no way to factor that. There is no common term. So what values of x would make the denominator 0? Well, for the denominator to be 0, our x squared would have to be negative 4. And since our squares are all positive numbers, there are no values of x. So the values of x that will make our denominator 0 are none. There are no values of x to make the denominator 0. Okay, so that was number 4, which is just like number 11 that I assigned as homework. So remember, what you're trying to find are values of x that you cannot use. Those are the values of x that will make the denominator 0, and those are not allowed. That's what you're looking for, the ones that are not allowed. So x equals 0 is not allowed. X equals 1 is not allowed. For part E, x equals plus or minus 2 is not allowed. For parts D and F, you can have any value of x. It doesn't matter what x is because x, in part D, x is not in the denominator, so there can't be any values of x that make it undefined. For part F, because it's x squared plus 4 and x squared has to be positive, there are no values of x that can make that, that can make the denominator 0. Okay, so let's move on and try number 5. Number 5 says reduce each of the following fractions to lowest terms. So let's start with part C. We have x squared over 4x. So we look to see what do we have as a common term between the numerator and the denominator. Well, our only common term is x. So if we divide both the numerator and the denominator by x squared divided by x is x. 4x divided by x is 4, so x over 4 is that fraction in lowest terms. Now let's look at part F. We have 5 times x plus 1 over 10. Okay, so 5 and 10 do have a common factor. Their greatest common factor is 5. So if I divide the numerator and the denominator by 5 divided by 5 is 1, 10 divided by 5 is 2. We will end up with x plus 1 over 2. Okay, let's jump down to part G. Part G is x squared over x times x minus 2. Our greatest common factor here is x. So x squared divided by x is just an x. X divided by x is a 1. So when we write this in simplest terms, we get x over x minus 2. And then one more problem from number 5. We'll do part H. We have 3 times x plus 7 divided by x plus 7 times x plus 3. So you can see that x plus 7 is a common factor in the numerator and in the denominator. If we divide both of those by x plus 7, we just get 1 in the top and we get a 1 in the bottom. And so we end up with 3 over x plus 3. So that was number 5, which is just like number 12 that is assigned as homework. So let's look now at number 6. Number 6 says change the following sets of fractions to fractions that have the same denominator. So this is just finding a common denominator. So we have 8 over x, and then we have 2 over x squared. What's the greatest common factor between x and x squared? That's going to be x squared. So I can just change my first fraction. What did I have to do to go from x to x squared? I had to multiply by x. So I need to multiply my numerator by x. 8 times x is 8x. So now to have fractions that have the same denominator, I have 8x over x squared, and I have 2 over x squared. So let's jump down. I'm sorry, I said that was part A. That's part C. So now let's jump down to part F. Part F says 2 over x plus 2 and 4 over x plus 4. Our denominators do not have any common terms. So what I have to do is multiply my first fraction by x plus 4 over x plus 4, and multiply my second fraction by x plus 2 over x plus 2. So when I multiply in my first fraction, 2 times x plus 4 is 2x plus 8, because 2 times x is 2x and 2 times 4 is 8. And in the denominator, I'm just going to write x plus 2 times x plus 4 and leave it in factored form. For my other fraction, I'm going to multiply out 4 times x is 4x, 4 times 2 is 8, and then that is over x plus 4 times x plus 2. So now we have a common denominator, and this is my pair of fractions. Okay, let's look at number 6, part G. Part G has 2x over 5, 5x over 2, and x over 10. Okay, between 5, 2, and 10, what is our common denominator? Our least common multiple is going to be 10. So I'm going to write each of these as a fraction of 10. I don't have to do anything to the last fraction because it's already a fraction of 10. So what did I have to do to 5 to get to 10? I had to multiply that by 2. So that means I need to multiply my numerator by 2. 2x times 2 is 4x. Okay, now for the second fraction, what do I have to do to 2 to get to 10? Well, 2 times 5 is 10, so that means I need to multiply my numerator by 5. 5x times 5 is going to be 25x. Notice this is a times 5, not a to the 5th power thing. And then I don't have to do anything to my last fraction. So my fractions are 4x over 10, 25x over 10, and x over 10. Okay, we're going to do one more from number 6. That's part H. Part H is 3 over x, 4 over x squared, and then 5 over x cubed. What is our least common multiple to make a common denominator here? That's going to be x cubed. So that means I'm going to write all of these as fractions of x cubed. And then my last fraction is already an x cubed, so I don't have to do anything to it. To get from x to x cubed, I have to multiply by x squared. So I need to multiply my numerator by x squared. 3 times x squared is going to be 3x squared. To get from x squared to x cubed, I needed to multiply by x. So that means I'm going to multiply my numerator by x. 4 times x is going to be 4x. So my fractions are 3x squared over x cubed, 4x over x cubed, and then 5 over x cubed. So those are my fractions that have the same denominator. So that's the end of the part 1 video. In the part 2 video, I will cover the rest of the problems. This was number 6, which is just like number 13 that I assigned as homework.